standing on a stretch of flat prairie in the far eastern corner of Yuma County, near the border where the terrain rolls off towards Kansas. There is nothing in the immediate field of view to suggest an extraordinary elevation. The Arikari River cuts a shallow, dry channel through layers of pale tertiary sediment washed down from distant highlands millions of years ago. The horizon is wide, open, and low. Yet the ground beneath this quiet grassland rests at exactly 1,010 meters above sea level. This flat riverbed is higher than the absolute maximum natural summits of 18 separate political territories across the continent. What is remarkable about this baseline is not that the terrain rises, but how quietly the entire continent was lifted beneath it without breaking the surface. How did a flat expanse of river gravel come to sit higher than the highest mountains of nearly 20 surrounding regions, while hiding a subterranean architecture that scientists are only now mapping in detail? For generations, travelers and early surveyors viewed the Great Plains as a vast, uniform lowland that merely served as an apron to the true alpine wilderness further west. That assumption was entirely reasonable for its time. To the eye, the transition from eastern river valleys to high altitude is so gradual as to be imperceptible over hundreds of kilometers. The first crack in this picture appeared when early geodetic surveys confirmed that the baseline elevation of the entire region rests on a massive, thermally supported plateau, creating a high-altitude realm long before the first true mountain ridges ever appear. Fact 35. The mountain of sand with no solid foundation. Nestled tightly against the rugged Sangre de Cristo Range within Alamosa and Saguache counties, the highest dune field on the continent defies standard mountain geology. Rising over 230 meters directly from the valley floor, these immense sand structures exist without a single outcrop of solid bedrock supporting their interiors. They are sustained by a complex hydrological and atmospheric trap within the San Luis Valley. Prevailing winds push fine sediment across the basin floor until the towering wall of the Sangre de Cristo Range forces the air abruptly upward, dropping the airborne sand at the base of the peaks. Medano Creek acts as a natural hydraulic conveyor belt, catching the shifting sand during spring runoff and carrying it back down to the valley edge, where the wind picks it up and drives it right back against the slopes. This creates a self-sustaining geological loop where the dunes maintain their immense height despite constant wind shifts. The entire field contains over 5 billion cubic meters of sand. Crucially, this immense mass rests upon a vast subterranean aquifer that keeps the foundation stabilized in an otherwise arid alpine basin, holding a dynamic balance across the high wilderness. Fact 34. The elevated baseline hiding in the eastern plains. Situated along the Arikari River channel in Yuma County, the lowest point of the territory presents a profound geographic paradox. Sitting at 1,010 meters above sea level, this shallow prairie depression occupies an elevation greater than the highest peaks of 18 different states and provinces across North America. The regional geography slopes continuously upward from the distant Mississippi basin, establishing an elevated foundation long before any alpine topography is visible on the horizon. Persistent erosion from ancient river networks has sculpted this grassland terrain, slicing shallow valleys into thick layers of tertiary sediment that washed out from rising western mountains tens of millions of years ago. It serves as a permanent physical reminder that the entire region operates within a specialized atmospheric and geological realm, where even the lowest agricultural lowlands occupy an altitude that rivals eastern mountain chains. Fact 33. The extinct volcanic complex above the timberline. Located within Larimer County inside Rocky Mountain National Park, Specimen Mountain stands at an elevation of 3,806 meters. Unlike the surrounding peaks built by tectonic compression and crustal uplifting, this prominent height is the preserved remnant of an extinct volcanic complex that was violently active during the Oligocene epoch, roughly 28 million years ago. Extensive eruptions of rhyolite ash, ash flow tuffs, and pitchstone constructed a massive volcanic center over thousands of centuries. Subsequent glacial erosion during the Pleistocene epoch stripped away the softer outer blankets of volcanic debris, exposing the hardened internal magma conduits and vent structures. Explorers along these high ridges frequently encounter unique mineral deposits, including opal, agate, and jasper, embedded directly within the exposed volcanic rock faces. The peak offers physical proof that this high alpine wilderness once trembled with intense geothermal heat and explosive eruptions, long before massive ice sheets carved the surrounding valleys. Fact 32. The billion-year gap in the Red Rock Canyon walls. The sheer monoliths near Grand Junction conceal a structural boundary known to geologists as a major unconformity. At the base of these vertical cliffs, Mesozoic sedimentary rocks approximately 200 million years old sit directly atop Precambrian metamorphic gneiss and schist that formed over 1.7 billion years ago. This sharp horizontal contact marks an era where over 1 billion years of terrestrial history has completely vanished from the local geological record. Either no sediment was deposited over that immense span of time, or entire ancient mountain ranges were completely eroded down to a flat plain before the red sandstone beds were laid down over them. This physical boundary can be touched with a single hand along the canyon trails, offering a direct, tactile connection across an unimaginable gap of missing time that continues to inform modern structural geology. Fact 31. The Slot Canyon Sanctuary hidden behind the waterfall. Box Canyon Falls plunges over 25 meters through an exceptionally narrow quartzite slot canyon, sheltering a delicate biological anomaly. This dark, high-humidity environment provides a primary nesting habitat for the elusive black swift, a highly specialized migratory bird species. The birds select these treacherous vertical rock faces because the sheer, wet walls prevent land predators from reaching their nests. Returning from wintering grounds in South America every summer, the swifts raise their young directly behind the deafening spray of the plunging waters. Geologically, the Slot Canyon was carved into ancient sedimentary strata by the intense erosive force of Canyon Creek, creating a protected microclimate with stabilized temperatures and constant high humidity. This rare combination of vertical rock architecture and hydraulic mist makes the site one of the most unusual high-altitude biological refuges in the region. Fact 30. The subalpine forest preserved in volcanic mud. Situated within Teller County, the fluorescent fossil beds preserve a detailed record of an ancient ecosystem overwhelmed by catastrophic volcanic events. Approximately 34 million years ago, during the Eocene epoch, explosive eruptions from the nearby Guffey Volcanic Center generated massive lahar flows, superheated avalanches of ash, mud, and water that raced across the prehistoric landscape. This mineral-heavy volcanic slurry swept into an ancient lake basin, instantly sealing off oxygen and preserving thousands of fragile organisms with remarkable anatomical precision. Paleontologists extracting samples from paper-thin shale layers have uncovered intact fossilized dragonflies, spiders, delicate leaves, and fish. Among the most striking features are petrified stumps of ancient redwoods, some measuring over 4 meters in diameter. These giant trees were turned to stone as silica-saturated waters slowly replaced organic fibers over centuries. The location remains globally significant because its high-altitude shale beds hold one of the richest paleobotanical collections on Earth, proving that a humid, near-subtropical forest thrived where subalpine evergreen woodlands stand today. Fact 29. The high-altitude cradle of ancient living pines. Spanning the wide, elevated basin of Park County, the region known as South Park hosts some of the oldest living trees on the continent. Along the freezing, wind-swept slopes of the surrounding mountain ranges, Rocky Mountain bristlecone pines thrive in environmental conditions that would kill most other plant species. Dendrochronological studies conducted on individual trees along these high ridges have verified living specimens exceeding 2,500 years of age. They endure by growing at an extraordinarily slow pace within nutrient-poor dolomite soils, producing dense, resinous timber that resists decay, insect damage, and fungal infection. The physical environment of this basin, sitting at an elevation of nearly 3,050 meters above sea level, creates a severe microclimate characterized by brief growing seasons and freezing temperatures. When structural sections of a tree die, a narrow strip of living bark can continue carrying nutrients to sustain a small cluster of needles for centuries. These resilient pines provide climate scientists with an unbroken physical record of atmospheric shifts stretching back over 2 millennia. Fact 28. The narrow chasm where sunlight rarely reaches the floor. Carved through the heart of Gunnison County, the Black Canyon of the Gunnison presents some of the steepest and narrowest vertical rock faces on the continent. The name derives from a direct solar reality. Certain constricted sections of the canyon floor receive less than 30 minutes of direct daylight each day. This condition occurs because the Gunnison River drops rapidly over short distances while slicing through Precambrian crystalline rock, primarily tough gneiss and schist that resist lateral erosion. Instead of widening out into a broad valley, the river acted as a vertical saw, cutting a gorge up to 820 meters deep, while leaving the canyon rim barely 330 meters wide at its narrowest point. The vertical walls create a permanent shadow zone below, where specialized mosses and shade-adapted plants thrive in perpetual twilight. The sheer granite drop stands as an enduring record of high-gradient hydraulic erosion grinding through nearly 2 billion years of solid metamorphic stone. Fact 27. The 14,000-foot peak held under historic land title. Situated in Costilla County within the southern reaches of the Sangre de Cristo Range, Culebra Peak occupies a unique administrative status. Among the 58 recognized peaks in the territory that exceed 4,267 meters in elevation, Culebra Peak is the only summit located entirely on private land. This legal status traces directly back to the historic Mexican land grant system of the 1840s, which established communal property boundaries long before the territory was integrated into modern administrative networks. Because access has been strictly regulated for generations, the high alpine ecosystem surrounding the summit has remained unusually pristine compared to heavily traveled public peaks. Fragile tundra vegetation, rare alpine flora, and bighorn sheep habitats remain shielded from the high volume of foot traffic that routinely wears down neighboring summits. It represents a rare intersection of colonial property records and modern ecological preservation in the high country. Fact 26. The dormant cinder cone beside the river corridor. Tucked into Garfield County along the main transportation corridor near Interstate 70, Dotsero volcano challenges the common assumption that regional volcanic activity ceased in the distant geological past. This basaltic cinder cone represents the youngest volcanic eruption in the entire region. Geological investigations confirm that the vent erupted approximately 4,200 years ago. The explosion occurred when ascending magma encountered shallow subterranean groundwater, triggering a steam-driven phreatomagmatic blast. This event excavated a crater roughly 400 meters wide and 90 meters deep into the existing terrain, spreading dark ash and scoria across the surrounding valley. A small lava flow poured down toward the riverbed, altering local drainage patterns. Classified as a potentially active volcanic feature, the site confirms that geothermal energy remains stored beneath the crust, waiting for the structural conditions that will trigger the next eruption. Fact 25. The thermal abyss, measured by automated sonar probes. Flowing constantly within Archuleta County, the Great Pagosa Hot Spring holds an official global benchmark as the deepest measured geothermal spring. For over a century, local surveys recorded mineral-rich waters discharging at average temperatures of 55 degrees Celsius, but the physical architecture of the underground feeder system remained entirely unknown. In August of 2011, a research team deployed an automated acoustic sounder and tethered plumbing probe into the central vent to map its subterranean profile. The instrument descended to a depth of 312 meters without contacting a solid floor or reaching the base of the aquifer conduit. Extreme thermal stress and rising hydraulic pressure halted the instrument's descent, leaving the ultimate depth of the hydrothermal reservoir unmeasured. Geothermal mapping indicates the system is fed by deep crustal faults, where surface precipitation descends several kilometers into the upper mantle, absorbs radioactive decay heat, and ascends rapidly through fractured bedrock. The massive discharge volume supplies clean municipal thermal energy, but the physical bottom of the spring remains outside empirical measurement. Fact 24. The labyrinth of ash spires mapped by satellite altimetry. Situated within Mineral County, the Wheeler geological area exposes a densely eroded landscape of volcanic ash formations. The remote complex features hundreds of isolated spires, narrow fins, and steep pinnacles carved into pale tuff beds. Geological mapping initiated by early regional surveys established that these structures originated during the explosive collapse of the Creed caldera roughly 25 million years ago. A thick layer of soft volcanic ash and fine pumice was capped by a thin mantle of dense, welded ignimbrite, which initially shielded the underlying layers from weathering. When stream channels cut through the hard upper cap, localized water erosion rapidly carved deep vertical grooves into the soft ash below. Aerial laser scanning and satellite altimetry have since documented that these fragile spires erode at rates significantly higher than surrounding granite structures, providing an active baseline for measuring high-altitude landform degradation. Fact 23. The glacial depression surveyed by deep seismic profiling. Located within Grand County at an elevation of 2,551 meters above sea level, Grand Lake stands as the largest and deepest natural body of water in the mountain system. Early bathymetric surveys using weighted line soundings established that the basin possessed an unusual profile compared to shallow alpine tarns. Subsequent seismic reflection profiling across the lakebed revealed a maximum water depth of 81 meters, underlain by a thick sequence of glacial till and fine lacustrine sediments. The basin was scoured into solid bedrock during the late Pleistocene epoch, when terminal valley glaciers retreated and left behind massive morainic dams that trapped alpine snowmelt. The stratified water column feeds directly into the headwaters of major transcontinental river networks, serving as a critical natural storage node for large-scale water diversion infrastructure engineered to supply eastern urban centers. Fact 22. The mountain slope monitored by continuous satellite radar. Creeping down a steep valley in Hinsdale County near Lake City, the Slumgullion earthflow stands as one of the most thoroughly documented active landslides on the continent. The initial mass wasting event occurred approximately 700 years ago, when an entire ridge face composed of altered volcanic tuff collapsed and slid nearly 6 kilometers into the valley floor, damming the lake fork of the Gunnison River and creating Lake San Cristobal. A secondary, younger section of the earthflow remains actively mobile today. Using ground-based global navigation satellite system receivers and interferometric synthetic aperture radar, geologists track the movement of this upper unit as it advances downward at speeds of up to 6 meters per year. This continuous displacement destroys surface vegetation, distorts local roadways, and provides researchers with a real-time field laboratory for measuring mass wasting dynamics within high-relief alpine environments. Fact 21. The radial dike swarm revealed through aeromagnetic mapping. Radiating across the landscape of Huerfano County around the Spanish Peaks, an extraordinary network of over 170 vertical igneous dikes cuts across regional topography. To early observers, these long, wall-like rock ridges appeared as artificial stone ramparts stretching uninterrupted over rolling hills. High-resolution aeromagnetic surveys conducted across the basin demonstrated that these surface features are part of a continuous subsurface radial fracture system. Millions of years ago, magmatic pressure beneath the Spanish Peaks intruded liquid rock outward into vertical fractures within the surrounding sedimentary layers. As surface erosion stripped away the softer sandstone and shale beds over millions of years, the harder volcanic rock walls were left standing up to 30 meters above the surrounding ground level. The resulting network serves as a textbook visual demonstration of subsurface magmatic plumbing exposed by long-term regional denudation. Fact 20. The geothermal spring system identified by gas chromatography. Tucked into the northern valleys of Routt County, a complex system of over 150 thermal mineral springs produces a distinct hydrochemical signature. Early 19th century trappers documented a rhythmic chugging sound resembling a steam-powered riverboat along the valley floor, created by pressurized carbon dioxide gas escaping through narrow mineral-encrusted vents. Subsequent railway construction and subsurface drilling fractured the shallow rock conduits, altering the acoustic venting mechanism. Modern hydrochemical sampling and gas chromatography have clarified the subsurface flow path. Surface water descends along deep fault zones, reaches geothermal heat sources, and dissolves trace elements including lithium, sulfur, and iron before returning to the surface at temperatures ranging from 10 to 65 degrees Celsius. These localized springs create high mineral microhabitats that support rare thermophilic bacterial mats absent from adjacent cold alpine tributaries, revealing how deep structural faulting influences surface biology across the high plateau. Fact 19. The High Head Waterfall mapped by hydraulic engineers. Plunging over a vertical cliff face at the terminus of a box canyon in San Miguel County, Bridal Veil Falls drops a total of 111 meters into a steep granite gorge. The sheer vertical drop was measured and mapped in detail during the late 19th century by industrial survey teams assessing regional hydroelectric potential. In 1897, engineers completed a high-head hydroelectric station perched directly on the cliff edge above the falls. The facility utilized the extreme gravitational energy of the falling water column to generate alternating current electricity, which was transmitted along high-voltage lines to power remote mining equipment across the district. Geological core samples show the cliff wall is composed of highly resistant quartzose sandstone that resisted glacial scouring, creating a vertical shelf where the regional drainage drops abruptly into the lower valley, leaving a stark record of structural control over mountain drainage networks. Fact 18. The granite gorge carved by deep hydraulic action. Carved through the heart of Fremont County, the Royal Gorge represents an extraordinary record of continuous fluvial erosion cutting through ancient bedrock. Over roughly 3 million years, the river channel has sliced through a massive plateau of solid Precambrian granite dating back more than 1.7 billion years. The resulting canyon walls drop over 380 meters, almost vertically to the water below, creating one of the narrowest and deepest granite chasms in the territory. The extreme geometry made the canyon floor a focal point of intense transit competition in the late 19th century, as competing rail companies maneuvered for access through the narrow corridor to transport silver ore out of the high country. Today, civil engineers continuously monitor the sheer granite walls for structural stability. Rockfall mitigation networks and acoustic sensors track microfractures in the ancient rock, ensuring that both industrial transit lines and structural bridges spanning the chasm remain safe from ongoing mass wasting processes. Fact 17. The high-altitude gemstone veins exposed on exposed ridges. Perched high within the Saguache Range of Chaffee County, Mount Antero conceals a rare mineralogical phenomenon near its alpine summit. Rising to 4,351 meters, the peak hosts the highest documented deposit of gem-quality aquamarine on the continent. These beryl crystals formed millions of years ago inside cooling granite pockets, where volatile, mineral-rich, magmatic fluids crystallized under specialized pressure conditions. Because these deposits sit above the tree line, extraction is strictly constrained by atmospheric conditions. Independent prospectors and geological researchers operate within a narrow seasonal window of just a few weeks each summer when the heavy snowpack melts. The location requires teams to navigate intense freeze-thaw weathering, high winds, and severe lightning hazards, illustrating how high-altitude alpine meteorology directly governs access to rare subterranean mineral structures. Fact 16. The high-altitude continental drainage divide. Winding along the boundary of Summit County, Loveland Pass serves as a primary hydrological node along the Continental Divide, separating two major drainage basins. Sitting at an elevation of 3,655 meters, the Alpine Corridor traverses a harsh mountain environment continuously modified by heavy snowpack accumulation and glacial erosion. Precipitation falling on the western flank enters mountain tributaries that flow toward the Pacific Ocean, while water falling on the eastern slope drains into river systems heading toward the Atlantic Basin. The pass is subject to extreme alpine weather, including wind gusts exceeding 160 kilometers per hour and annual snowfall totals often surpassing 760 centimeters. Transportation authorities maintain an extensive network of avalanche control installations and structural shelters to keep the high-altitude transit corridor open, managing a continuous boundary between severe weather and vital infrastructure. Fact 15. The tilted sandstone monoliths along the mountain front. Rising sharply above the valley floor in Boulder County, the iconic rock fins known as the Flatirons showcase severe structural tilting along a mountain front. These 5 prominent slanted sandstone slabs line the eastern slope of Green Mountain, forming a distinct visual boundary between the plains and the high peaks. Geologically, the rock beds belong to the Fountain Formation, consisting of coarse gravel and sand deposited by ancient river systems roughly 300 million years ago. Originally laid down in flat, horizontal layers, these massive sedimentary units were forced upward during tectonic mountain-building events approximately 45 million years ago. Tectonic compression tilted the entire formation to a steep angle of nearly 50 degrees. Subsequent surface erosion stripped away the softer overlying soils, leaving the hard sandstone faces completely exposed. Today, these vertical rock faces create isolated microclimates along their base, supporting specialized cliff-nesting bird populations while acting as natural structural barriers against urban expansion. Fact 14. The ancient seabed tilted into vertical fins. Located in El Paso County, Garden of the Gods displays dramatic upthrust rock formations created by intense tectonic compression. The site features towering fins, narrow spires, and balanced boulders composed of bright red and white sandstones. These sedimentary layers were originally deposited in horizontal beds within ancient coastal and dune environments hundreds of millions of years ago. However, major mountain-building events compressed the regional crust, snapping and bending the solid rock layers until they were thrust vertically into the open air. Over millions of years, selective wind and water erosion carved away the surrounding softer rock matrix, leaving behind vertical slabs that rise over 90 meters into the air. Geotechnical teams actively monitor these exposed formations, measuring tilt, wind erosion rates, and thermal stress to preserve the structural integrity of these elevated sedimentary remnants. Fact 13. The weeping sandstone cliffs that sustained human settlement. Situated in the far southwestern corner of Montezuma County, the plateau structures of Mesa Verde contain a specific hydrological feature that enabled long-term human habitation. The canyon walls consist of porous, cliff-house sandstone overlying dense, impermeable layers of shale. Rainfall and melting snow slowly percolate down through the sandstone until hitting the shale barrier, forcing the water to travel horizontally and emerge along exposed cliff faces as natural seep springs. Over thousands of years, this continuous moisture triggered localized frost wedging and spall erosion, hollowing out deep natural alcoves within the sheer canyon walls. Ancestral populations recognized these sheltered alcoves as permanent water sources and secure structural foundations, building complex stone settlements inside the natural rock hollows over 700 years ago. The site demonstrates how localized hydrological flow through sedimentary rock directly determined human settlement patterns within an otherwise arid plateau region. Fact 12. The fossil bar exposed in Jurassic sandstone. Located within Moffat County, near the northern boundary, the quarry at Dinosaur National Monument preserves an extraordinary concentration of prehistoric fauna. Approximately 150 million years ago, during the late Jurassic period, a high-energy river system swept across this basin, carrying the remains of dead organisms during severe seasonal flooding events. The heavy bones accumulated along a submerged sandbar, where they were buried under thick layers of river sediment and saturated by mineral-rich groundwater that petrified the organic structures over centuries. Tectonic uplift during the Laramide orogeny subsequently rotated the ancient riverbed upward, tilting the fossil-bearing sandstone layer to a steep angle. Today, the exposed rock wall displays over 1,500 individual bones belonging to species including Allosaurus, Apatosaurus, and Stegosaurus. Paleontologists monitor the rock face continuously, using laser scanning to measure how ambient atmospheric exposure affects the structural integrity of the petrified bone matrix. Fact 11. The mountain basin without a surface outlet to the ocean. Spanning across a high-altitude desert region in Saguache and Alamosa counties, the San Luis Valley contains a closed hydrological basin covering over 7,700 square kilometers. Ringed completely by the Sangre de Cristo and San Juan mountain ranges, surface water entering the northern portion of the valley cannot drain outward to any ocean. Snowmelt and rains sink directly into thick layers of unconfined volcanic sediment, recharging a subterranean aquifer that has remained trapped within the structural basin for millennia. Intense surface evaporation leaves behind concentrated mineral deposits, creating alkaline flats and seasonal wetlands that host migratory bird populations. Engineers have constructed complex pumping and diversion networks to draw water from this deep underground reservoir into the Rio Grande system, demonstrating how subsurface geological containment continues to govern regional water management. Fact 10. The fragile Travertine Dam hanging over the canyon wall. Suspended along the cliffs of Glenwood Canyon in Garfield County, Hanging Lake represents a delicate geochemical masterpiece. The lake formed along a localized fault zone where a section of the canyon wall collapsed, creating a natural basin during prehistoric times. The body of water is retained by a fragile rim of natural travertine, formed when dissolved calcium carbonate precipitates out of cold spring water and encrusts organic matter along the edge. Over centuries, this slow chemical process built a natural carbonate dam, holding back the alpine meltwater. Because the travertine rim is exceptionally brittle, minor mechanical shocks or changes in hydrochemistry can cause structural failure. Conservation teams maintain strict access restrictions around the site to preserve the fragile dam architecture from rapid collapse. Fact 9. The underground karst maze in ancient limestone beds. Hidden deep within the ridges of El Paso County near Manitou Springs, the passages of Cave of the Winds reveal millions of years of subterranean dissolution. The cavern network is carved into the Leadville limestone, a massive sedimentary unit deposited over 300 million years ago when shallow marine waters covered the continent's interior. Acidic groundwater seeped through structural fractures in the carbonate rock, dissolving internal channels to form a multi-level labyrinth of silent chambers and narrow crawlways. Regional tectonic uplift eventually drained the water, allowing mineral-laden drips to deposit stalactites, stalagmites, and rare helictites that branch in all directions. The cave system maintains a constant interior temperature and serves as an isolated subterranean habitat, illustrating how long-term chemical weathering carves extensive structural networks beneath the surface. Fact 8. The continuous highway engineered across high alpine tundra. Scaling the granite ridges of Clear Creek County, the Mount Blue Sky Scenic Byway reaches an elevation of 4,307 meters above sea level, terminating just below the summit peak. Constructed in the early 20th century, the paved road passes through multiple ecological zones, ascending from subalpine evergreen forests to fragile tundra environments. At these extreme heights, civil engineers confront permafrost layers beneath the roadbed and continuous freeze-thaw cycles that buckle asphalt surfaces every season. The highway provides direct vehicular access to high-altitude atmospheric monitoring stations, showing how human infrastructure can penetrate extreme alpine terrain while requiring constant geotechnical maintenance. Fact 7. The unregulated river system driving native fish dynamics. Flowing through the sandstone canyons of Routt and Moffat counties, the Yampa River represents a rare hydrological baseline as one of the last major untamed tributaries in the Colorado River Basin. Operating without major dams or large-scale diversion projects along its main channel, the river retains its natural seasonal flood profile. Heavy spring snowmelt drives high-volume water surges through the narrow rock gorges, moving sediment and clearing gravel bars. This natural flow regime is critical for maintaining habitat conditions required by endangered native fish, including the humpback chub and Colorado pike minnow. The surrounding canyon corridor preserves pristine riparian cottonwood forests that have largely disappeared from regulated rivers, offering researchers an active benchmark for studying natural fluvial mechanics. Fact 6. The massive volcanic collapse that reshaped the regional crust. Deep within Mineral County, the Creed caldera marks one of the most violent volcanic events recorded in the region's rock history. Approximately 25 million years ago, an explosive eruption within the San Juan volcanic field expelled hundreds of cubic kilometers of superheated ash and pyroclastic material. The sudden evacuation of the underlying magma chamber caused the overlying volcanic roof to collapse inward, forming a structural basin several kilometers wide. Over subsequent millennia, this massive caldera filled with water, depositing lakebed sediments that later hosted mineral veins rich in silver and lead. Today, the eroded caldera rim provides geologists with a clear visual record of structural collapse, documenting how explosive igneous activity permanently altered the regional landscape. Fact 5. The river channel cutting perpendicularly across a sunken salt valley. Situated in western Montrose County, Paradox Valley presents a striking topographic anomaly where the Dolores River flows directly across the middle of a wide valley, cutting through parallel canyon walls rather than following the length of the basin floor. This layout resulted from subsurface salt tectonics operating over millions of years. An underground salt dome collapsed as groundwater dissolved the mineral layers, causing the overlying sedimentary rock to drop and form a deep valley long after the river had established its course. The river maintained its path, slicing straight through the rising valley rims. Hydrologists study this rare interaction between surface drainage and subsurface mineral dissolution as a classic example of landscape inversion. Fact 4. The open-pit molybdenum mine operating on the Continental Spine. Perched along the Continental Divide in Lake County, the Climax Mine represents a large-scale industrial operation adapted to extreme altitude. Operating at 3,444 meters above sea level, the mine extracts molybdenum from a massive ore body formed by ancient hydrothermal mineralization within fractured granite. Extracting ore at this elevation required specialized engineering to maintain heavy equipment through severe winter temperatures and heavy snowpack. Decades of excavation have significantly altered the local surface topography, creating vast terrace benches across the mountain face and requiring dedicated water treatment facilities to protect downstream subalpine watersheds. Fact 3. The fragile sedimentary towers prone to rapid rockfall. Rising within Pitkin County, the Maroon Bells display a deceptive structural composition. Unlike the hard Precambrian granite that forms most high summits in the region, these twin peaks consist of soft, sedimentary siltstone and mudstone belonging to the Maroon Formation. Deposited roughly 300 million years ago by ancient river systems, these reddish sedimentary layers are brittle and highly vulnerable to severe freeze-thaw weathering. The constant fracturing of the rock faces causes frequent rockfalls, creating extensive scree slopes around the base and demonstrating how rock composition directly dictates slope stability in high alpine environments. Fact 2. The narrow-gauge rail tunnel driven through the continental granite core. Straddling the high alpine boundary between Chaffee and Gunnison counties, the historic Alpine Tunnel stands as an early monument to mountain transit engineering, piercing the Continental Divide at an elevation of 3,512 meters. Engineers and workers dug through solid granite and fractured fault zones using basic tools and explosives, encountering unexpected subterranean water veins that required extensive timber support. Although seasonal avalanches and severe weather forced its abandonment, the tunnel remains a permanent physical mark where industrial transit directly penetrated the primary drainage barrier of the continent. Fact 1. The subterranean limestone labyrinth sealed beneath the Plateau wilderness. Deep beneath the high plateaus of Garfield County, Groening Cave forms the longest mapped subterranean network in the territory, extending over 24 kilometers through the ancient Leadville limestone layer. The cave features a complex, multi-level maze of narrow fissures, vertical drops, and large chambers formed by acidic groundwater dissolving carbonate rock over millions of years. Maintained at a constant cold temperature year-round, the isolated environment preserves delicate mineral formations and specialized cave-adapted organisms. It stands as a reminder that vast, fully developed structural systems remain hidden directly beneath the surface of the mapped landscape. What had kept this landscape misread for so long was not a lack of effort or a shortage of maps, but the simple assumption that surface appearance matched subterranean reality. While the general outlines of these peaks and valleys are well established, the exact mechanics of deep groundwater movement, permafrost decay, and structural slope stability remain actively researched. The maps we rely on present a settled surface, yet the physical ground beneath them continues to shift, erode, and emerge according to forces that operate far beyond human timelines. Which of these geographical features in your own province or territory has always seemed the most unexpected to you? Share your observations in the comments below, and consider subscribing to follow our ongoing geographical investigations.